Welcome back, Hampshire chemistry students. In today's video, we're going to be taking a look at some more examples of some titration problems. Okay, so we're going to be looking at some slightly more complicated examples, one where the reactions are a little bit trickier, okay, but we're going to still follow the same basic pattern as we have been for all of our titration problems. So let's take a look at an example of one, where I've got a sample of oxalic acid. Okay, oxalic acid is used in beehives, and it's used to help kill off the parasites that are present in those hives. And one of the beekeepers sadly left a sample unlabeled. Now they want to make sure they know this concentration, because if it's too strong, it might kill the entire hive and all the bees, and if it's too weak, it won't kill off the parasites and the bees will still die. Okay? But so we take 20 milliliters of that acid. We want to find its concentration. And in order to do so, we use 250 milliliters of NaOH, of sodium hydroxide. And that sodium hydroxide has a known concentration of 0.05 molar. Okay? So let's set up our same 4 steps that we used, our same exact ideas, that we need to write an acid reaction. We need to find the moles of base that we used, convert those moles of base into acid, and then find the concentration of said sample. Okay, so if you haven't already, why don't you try and pause and write that reaction between oxalic acid and sodium hydroxide. Okay, if you want to see what it looks like, take a look now. Okay. So oxalic acid is C2O4 is the polyatomic ion oxalate. And make sure you check your formula, as oxalate's a -2, so it needs H2 in front of it. This is sometimes called a diprotic acid because it has 2 hydrogens. You can sometimes also find triprotic acids like phosphoric acid. That's H3PO4. Okay. But no, let's keep going though. We're going to react with sodium hydroxide to make water and our salt in this case. Now notice that we did need to balance this reaction. We needed 2 sodium hydroxides and 2 waters. Okay, that's going to be important as we move into some other steps. Okay, but our next step is that we need to find the moles of base. Okay, we know we used 250 milliliters of 0.5 molar. So we can use our molarity equation to help us find our moles of base that we do not know. So some quick multiplication, right? Bring that 0.25 over. We should find that we have 0.125 moles of sodium hydroxide. Once we've found this, we now need to convert those moles of sodium hydroxide into moles of base. Now, if you remember when we looked at the reaction last time on our videos, this was a 1-to-1 ratio. But notice now this is not a 1-to-1 ratio. It is a 1-to-2 ratio. So this is our big difference in a problem like this one, is that we now have to make sure we incorporate our coefficients. And our moles of base are not going to be equal to our moles of acid. In this case, since we're essentially dividing by 2, we're going to have half as many moles of acid. So we went from 0.0125 moles of base into 0.00625 moles of our oxalic acid. Okay? If you forget this step and do a 1-to-1, your concentration will be way, way off, and all those poor bees could die. Nobody wants the bees to die. Okay? So, in our final part, we need to find the concentration of our actual sample. We know that our amount of moles of acid, that's that 0.625 we just found, and we're dividing by the liters of acid. Again, a common mistake, do not use your volume of base here. We want to go all the way back up to the top to find the amount of acid that we had when we divide our situation. Okay? So our final answer is going to end up being 0.31 molar oxalic acid, because we're dividing those 2 final amounts. Again, the big difference here is that we have a different ratio. Sometimes this might be a 1-to-2. Sometimes it might be a 2-to-1. It could be a 1-to-3 or a 3-to-1. Make sure you balance your equation correctly, and then that will help you find the correct answer every single time. If you have any other questions on titration problems, don't hesitate to ask or email or contact. But until then, guys, I'll see you in the next video.